So, sorry I was not here Tuesday to celebrate the victory. So, we got some residual victory here. It's also the first day of Dallas Stars hockey, so we're all celebrating that. Well, Dallas does.
Wait.
Our,
No,
it's next Monday.
Monday,
He posted on Google Classroom.
I did.
He said, "Be prepared."
Be prepared. If I don't see a sea of blue, white, silver, I'm gonna. No pizza party.
I don't know the opposite too.
blue, white.
Okay, there you go. Now, here we go. Did y'all write holiday for Monday? Did you write sub for Tuesday, PSAT for Wednesday? And then this is going to be the really easy warm-up. So the warm-up, we need to find the vertex. You could graph it and do menu 5-1 and trace it, but that's too many steps. It's right there in the equation. Look at this number and this number. What's the vertex? Okay, so what's, again, x comma y. What's the vertex? 4 is wrong. Insider's what? Insider's what? Lie. So -4, comma what? -7. The outsider does not lie. The insider does lie. Those two numbers can get you the vertex. Opposite of this, not the opposite of that. That's it. Now, today we're going to take these absolute value equations and solve them.
That was it.
Oh, yes. Right. We have 2 days of work to squeeze into 1 day. It's supposed to do.
I checked him on the thing. Why did you have a test? Like an absolute test. Did I take it? Is that here? Oh. Then we went to 5 and below. I was pushing my sister to the car.
Here we go.
The blue one, and I stole it.
By the way,
The car.
Sunday night, roasted eagle. Watch out. Who? The Eagles? Yeah, they're going to lose. No, Cowboys are going to win.
The Cowboys are only winning because what's his face isn't playing. Once he starts playing, he's like,
They play Sunday night.
you know what I'm talking about? Your quarterback. What's his face?
That's correct.
Yeah, he's like he gets hurt, but that's why y'all are winning because he's not playing. Once he starts to play again, y'all gonna start losing.
All right, let's do this. Let's talk about some math. And here we go. Okay. Now, this first part is not in your notes. You can write it off to the side if you'd like to. It says to define absolute value. Here we go. Bam, bam, bam. So, if you don't write it down, you got to just know this in your brain. It will be posted on Google Classroom if you need it later, okay? Is everyone looking up here? New stuff today. Now, absolute value of a number is always non-negative. That means it's always either positive or 0. It is written as the vertical lines x, right? And it's the distance from 0. So let me make this as easy as I can make it. Did I not give you a... Oh, okay. Here's the easiest way you can do it. Is everyone looking and listening with both ears? Please. Black shirt too. Spike dirt sheds. All right. Now here's the deal. If it's a negative number, absolute value makes it a positive number. And if it's already positive, it stays positive. That's it. So think about it as absolute value is the ultimate optimist because it always stays positive. Okay, so again, every negative number, when you make it an absolute value, turns it into a positive. 0 stays 0, and positive stays positive. Cool. So what does an absolute value do to a negative number? Ladies and gentlemen, let's try this again. When you take an absolute value of a negative number, it makes it into a positive number. So the question I asked, what does an absolute value do to a negative number? It makes it a positive number. Does it change positive numbers? No, it makes them stay the same. Okay, all absolute value does is make sure it's positive. Negatives turn positive, positives stay positive, zero stays zero. Okay, I've said it a few times, it's right there, but let's talk about possible solutions. Okay, we're going to solve things today. You need to know this, so you can write this down somewhere or just soak it up with your brain. Ready? Look right here. If you have a absolute value equal to a negative number, that's going to give you no solution, okay? So if you're going to write this, don't write it underneath example 1 because we need space to do example 1 later, okay? So again, if you have an absolute value and it equals a negative number, that's no solution, okay? Here's why. If you had an absolute value graph that did not cross the x-axis, it would have no solution. Do y'all remember the solutions have to cross the x-axis? That's another name for an x-intercept solution. Okay. What about one solution? So if an absolute value equals 0, then it has one solution. You can solve it and get one solution. So here's an example of what it might look like on a graph. It would touch at one point, so it would have one solution. Okay. So again, if the absolute value equals 0, it has one answer. If an absolute value equals a negative, it has no answers. But if an absolute value equals a positive number, then you're going to end up with two answers. So think of something like this. It crosses the x-axis twice. Okay, do y'all see my little sketches? If it doesn't cross at all, that's because it equals a negative, no solution, no crossing. If it equals 0, then it touches once, bam. And if it equals a positive, it touches twice. Okay, what we're going to be doing today is mostly that last column. I'm going to show you how to get the two answers from an absolute value. Okay, this will be posted in the Google Classroom eventually, but I do want y'all to do example 1, 2, and 3 with me right here, right now. Okay, so I'll let y'all write this, what you want, write down what you need to right now. I'll give you a minute, but we got to do example 1 together. So go ahead and get that down. Okay, here we go. Now, on the left side of your notes, it gives you some steps on how to do this. Step 1, if your absolute value, the vertical lines, if there's anything next to it, you need to get rid of that first, okay? So you're isolating the absolute value bars. Step 2, if it equals a positive number, then you're going to split it into two cases, a positive and a negative case. I'll show you how to do that in a minute. Step 3, solve for x. Once you get your two values, that's your two solutions, okay? And you can check and verify your answer. So everybody, one second. Example 1, is everyone with me on example 1, okay? I need to solve this first for the absolute value bars. So what's next to the absolute value bars that I need to get rid of? What are the two things? So the -3 and what else? The 5 in front. So the 5 in front and the -3 after, which one do I need to get rid of first? Okay, we usually get rid of the loner, right? Does everyone see that -3? It's a constant. I'm going to get rid of the -3. How do I get rid of a -3? Adding 3. So everybody, underneath that -3, go ahead and put +3 on both sides. All right. So it cancels out on the left. And then on the right, 12 plus 3 is 15. So I'm going to bring down the left side. Good. So 5 in front of the bars is multiplying, so the opposite would be to divide. Okay. So yes, before we get inside of those absolute value bars, we get rid of this 5. So let's divide by 5 on both sides. Okay. It does cancel out on the left. What's 15 over 5 on the right? 3. Okay. So I said queso. So we have absolute value of x plus 4 equals 3. Now y'all tell me, see what you remember from a few minutes ago. Does this have no solution, one solution, or two solutions? Okay, so it has one solution if it equals 0. So if this 3 was a 0, it would be one solution. This is a positive number. Okay, so do positive numbers give me two solutions or none? What do you think? Two solutions. Okay, so let me review real quick. If your bars equal negative, then there's no solution. You're done. You just put no solution. Okay, but if the bars equal to 0, you solve it for one solution. And like this example, if your bars equal a positive number, you're going to split it into two equations with two solutions. Okay. Is everyone listening and looking up here? Okay. So here's the crucial step. Is everyone looking? Step number 2, remove the absolute value bars. And what you're going to do is you're going to have two equations equal to a positive 3 and then one equal to a negative 3. So check it out. Everyone write these two columns, positive and negative. So the x plus 4 is going to equal a regular 3, and the x plus 4 is going to equal a negative 3. Two equations now.
You really do that.
Okay, so now I believe in y'all from the early in Algebra 1 that you can solve these one-step equations. How would I solve x plus 4 equals 3? What do I do? Get rid of that loner 4. The opposite of positive 4 is minus, so minus 4 on both sides. And I get 3 minus 4. What do I get? Negative 1. So x equals negative 1. That's one of my solutions. Now in the other column, again, to get rid of a positive 4, we're going to subtract 4 on both sides. What's negative 3 minus 4? Negative 7 is correct. So we have two solutions, okay? Now, the second half of the notes, I'm going to show you how to put that on a number line, but spoiler alert, that's just 2 points. Negative 1, negative 7, boop, 2 dots, okay? But that's how you do this. So this is how you solve a positive case where you have two solutions. You can flip it over to example 2. We're going to try the next one, and the next one, and the next one. So am I good to flip this over? Who's still getting this down? Dragon Ball Z. All right, example 2. Here we go. Here we go. Oh yeah, I forgot. You can check your work, but that's cool and everything. All right, example 2. Here we go. Now, what's weird about this? Okay, so it's kind of flipped around than what we normally would see. So your first step, you can actually just kind of flip everything around, put the absolute value back on the left side, put the equals 8 on the right side. So I would suggest that. Technically, you can still do it, but whatever. Okay, it's nice when things are the right order. Just saying. Okay, so the 2x plus 6 in the bars plus 8 equals 8. Who knows what I might do first to solve for those bars? Okay, we're going to get rid of the positive 8 by subtracting 8 on both sides. So here we go, minus 8, minus 8. What is 8 minus 8? 0. Now, if it equals 0, it's not no solution. There's one solution, okay? So when you get to this situation where it equals 0, keep going, okay? The thing is, it won't split into 2 because there's no such thing as a positive 0 and a negative 0. 0 is just 0, okay? So here's the deal. When it's equal to 0, you basically just drop those bars, okay? Drop those fire bars. Oh, no, okay. You just drop those bars. Now, we get 2x plus 6 equals 0. Can you solve this two-step equation? Sure you can. How do I get rid of that loner? What do I do first? No. How do I get rid of the loner? How do I get rid of the 6? Minus 6 on both sides. 0 minus 6 is what? Negative 6. And then to get rid of that 2, what do I do? Divide by 2. What do we get? Negative 6 over 2. Negative 3. Now, if I asked you to put that on a number line, you would put 1 dot at negative 3. Dot. Wait, what? That one solution. No, sorry. When the bars equal a negative, that's when it's no solution. But after you solve it, negatives are okay. Whatever. Okay, example 3, ready? Oh, you can also check your solution, that's great. Example 3. Now, I have a coefficient in front of the bars. What should I do first to get rid of that negative 2? So negative 2 is being multiplied in front of it. So the opposite of multiplying is dividing by what? Negative 2, the exact same number. Okay. So again, number in front, divide by the exact same number. So we're dividing both sides by negative 2. By the way, it should say negative. What is 10 over negative 2? Negative 5. Okay, so bring down absolute value bars x minus 1 equals negative 5. What do you notice? So if it equals a positive, there's 2 solutions. This equals a negative 5. If it equals 0, it'd be one solution. Let's make a little key here. If your absolute value bars equal a negative, then there's no solution. If it equals 0, then there's one solution. And if it equals a positive, there's 2 solutions. Say what? Because it was being multiplied out front. The inverse operation, the opposite is to divide. Okay, so since my bars equal a negative number, I'm actually done. I just put no solution. Now, we could do example 4 and 5, but instead, we're going to just jump to the notes that the second notes, because we're doing 2 notes in one day, because it's not that hard. Ready? So, everyone look at the 3.3b absolute value equation graphs. So is everyone done with example 3? Example 4 and 5 are fun for you to do on your own sometime when you're bored. Today or something. Okay, so skipping on by, For the people on the video, this is what it looks like if you wanted to check your answers for number 4. And then for example 5, this is what the answers are if you wanted to check it and check it out. All right, now here we go. All right. Everyone's looking. If I have an absolute value of 4, once absolute value equals a positive number, you split it into 2. So x equals 4 or x equals negative 4. Okay? So remember, positive number. So you split it. So now I have 2 answers. I kind of already told you this, but how do I take those answers and put them on a number line? You're just putting points. Okay? So put a point at 4. Go ahead and put a point at negative 4. That's it. You're not shading in between because it's not an inequality. Okay, so equal sign means you just put a dot. It equals 4. It equals negative 4. That's it. So can y'all put 2 dots on a number line? Yes. Okay, I believe it. So let's try it from the ground up. Example 1. You ready? Hey, DBZ. Hey. Let's try and hit the off button. All right. Oh. I'm going to turn it all the way up, so you'll be very uncomfortable. All right. But seriously, example 1. Ready? So you already have this written down, right? 3x absolute value plus 2 equals 8. What should I do first to solve for the absolute value? Minus 2 on both sides. Scratch. By the way, if you don't have to write the right side if you know what it is, okay? So 8 minus 2 gives me what? 6. So I have an absolute value equals a positive 6. How many solutions will I get out of that? 2 solutions, because it's positive. 0 is 1 solution, negative is no solutions, okay? Now, once I'm here, this is where I'm going to do the split into 2 equations. So 3x is going to equal a positive 6, and 3x is going to equal a negative 6. It's going to look like this. So let me make sure we understand this step. Once you have the bars equal to a positive, you have to make 2 equations. This is where it splits, right? Now, could you solve each of those? How do I get rid of the 3 in front of x on both of them? Divide, because it's being multiplied, it's coefficient. So on each one, divide by 3. Oh my gosh, it looks ugly. Divide by 3, divide by 3. And if I do it on one side, I'm going to do it on the other side. So the 3's cancel. 6 divided by 3 is 2. The 3's cancel. Negative 6 divided by 3 is negative 2. Now, on your notes, you have a number line. Can you plot those 2 points on your number line? Bet. Hold on. We're almost done. So put a point at negative 2, put a point at positive 2, and you're done zone with that one, right? 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 All right. So one more example, then we're done with the notes, that is. Ready? 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 Here we go. Example 2, I got this equation. What should I do? Let's get rid of that minus 2. How do I get rid of the minus 2? Plus 2 on both sides, baby. These cancel out. What's 19 plus 2? 21. How do I get rid of that 3? Divide both sides by 3. They cancel out on the left. Okay, I'll slow down for a second. Now, the bars equal a positive number. How many solutions is that? 0, 1, or 2? Positive is 2 solutions, so you're going to split it into 2. The 4x minus 5 is going to equal 7, And the 4x minus 5 is going to equal a negative 7. Like so. So make sure you rewrite these two equations. And if you're a pro, you can solve those real quick. I think all of y'all are super pros. Because you had the most amazing algebraic reasoning teachers and geometry teachers. Wow. 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 I think I did.
Are you crying? Don't cry.
All right, so let's solve this. Ready? How do I get rid of the minus 5? I clearly taught you to add 5. All right, so add 5 to both sides. These cancel out. Bam, bam. What's 7 plus 5? Wow, I didn't teach you to add like that. All right, so 7 plus 5 is 12. And then negative 7 plus 5 is negative 2. All right, and then last step to get rid of the 4s, we're going to divide both sides by 4, right? Hey, wake up. So we divide by 4 on both sides, and divide by 4 on both sides. What is 12 over 4? 2 is absolutely wrong. 12 over 4 is 3. And then negative 2 over 4, negative 1/2. Could you plot those two numbers on a number line? I bet you can. Here we go. All right, so put a point at 3, put a dot there, and then put a dot. So you put a dot at 3, and then negative 1/2 is between 0 and negative 1 to the left. So negative 1/2. So could you solve these absolute values and then plot them on a number line? That's what I have for you today. Now this original one was two-sided, but I took off one side of it, but I also added the little number lines on here. They're blank, so you put the numbers however you like on here. But we kind of have to like